Chapter number 7, miscellaneous exercise, question number 3. A committee of 7 is to be formed from 9 boys and 4 girls. In how many ways this can be done if the committee consists of these following ways? So in first part, a committee should have exactly 3 girls. Okay. So in a committee of 7, we have 3 girls. Okay. So this means that remaining members would be boys. Therefore, the committee will have, in first case, 3 girls and 4 boys. So number of ways of selecting boys would be equal to 9C4. Okay, and number of ways of selecting girls, that is 3 girls, would be equal to how much? 4C3. So total ways of selecting the committee would be equal to 9C4 into 4C3. Four C3 is 4. 9C4 is equal to 9 factorial upon 5 factorial into 4 factorial. This would give 9 into 8 into this 7 into 6. 5 factorial cancels out, so I am going to have 4 into 3 into 2 into 4. These two terms cancel out. 6 factorial 6 and 6 cancels out. So the number of ways in which the committee would be formed would be equal to 72 into 7, which would be equal to 504, which is our required answer for the first part. For the second part, we have the committee should have at least 3 girls. Okay. Total number of girls are 4 and boys are 9, and a committee has to be formed of 7. Okay. So the number of ways of selecting the committee would be equal to, here it has been said that the girls should be at least 3 in a committee. So this means that the girls can be 3 or 4, because maximum 4 girls are there to be selected. So the committee will have 3 girls or 4 girls. So in first case, when we have 3 girls, then the number of boys would be how much? Number of boys would be 4 boys should be there in the committee. So total number of ways of selection would be equal to how much? 4C3 into 9C4. Okay. So this will be equal to 4 into 9 factorial upon 5 factorial into 4 factorial. So this will again be equal to 504. Okay. In the next case, when we have 4 girls, then 3 boys would be there to form a committee. So number of ways of selection would be how much? This will be equal to 4C4, that is the number of ways of selecting 4 girls out of 4, and into number of ways of selecting 3 boys, and the boys are total 9. Therefore this will be 9C3. Okay, so this will be equal to 1 into 9C3. 9C3 is equal to 9 factorial upon 6 factorial into 3 factorial. So this would be equal to 9 into 8 into 7 into 6 factorial. 6 factorial in the denominator is going to cancel out. This is going to become 6. 3 factorial will is going to become 6. 3 3s are 9, 2 is left, 4. So this will be equal to how much? 12 7s are 84. So total number of ways of selection would be equal to 588. Okay. For the third part, it has been given at most 3 girls. So this means that maximum number of 3 girls could be there. 3 girls could be there in the committee, or 2 girls could be there in a committee, or 1 girl could be there in a committee, or no girl. None of the girl is selected in a committee. Okay. So the total number of ways of selection would be 3 girls, then 4 boys would be taken, 2 girls, then 5 boys would be taken. If 1 girl is taken, then 6 boys would be taken in the committee, or if none of the girl is being taken, then 7 boys would be there in a committee. So number of ways of selection would be equal to the number of ways of selecting 3 girls and 4 boys, that is 4C3 into 9C4 plus 4C2 into 9C5 plus 4C1 into 9C6 plus 4C0 into 9C7. Okay, this we have calculated before also, so we are going to get this as 504. Okay. Four C2 is equal to 4 factorial upon 2 factorial into 2 factorial, and 9 C5 is equal to 9 factorial into 5 factorial into 4 factorial. 4 C1 is equal to 4. 9 C6 is equal to 9 factorial upon 6 factorial into 3 factorial. 4 C0 is equal to 1. So 9 C7 can be written as 9 factorial into 7 factorial into 2 factorial. So this is equal to 504. This on solving would give us 756. This is going to give us 336, and this will be equal to 36. Okay. The calculations are very simple, so I'm just writing the values. Okay, and on totaling, I'm going to get this as equal to 1632. So these many ways are there for selecting a committee. Okay.